All right, let's get ready for a heavyweight fight in the world of computing. In one corner, you've got the reigning champion, the NVIDIA RTX 4090, and in the other, the challenger that's ready to take that crown, the brand new RTX 5090. This is the showdown for anyone serious about AI. So, here's the big question on everyone's mind. Is the RTX 5090 this massive, revolutionary leap forward that you just have to upgrade to? Or is the mighty 4090 still the smarter, more practical pick for running AI models on your own machine? Well, let's find out. Okay, so here's how we're going to break it all down. First, we'll set the stage for this GPU clash. Then we're going to get right into the raw specs head-to-head. After that, we'll dig into what makes the new Blackwell architecture so special, see how that all translates to real-world AI performance, and finally help you figure out which one of these beasts is the right one for you. So let's set the scene here. I mean, yeah, these cards are absolute legends for gaming, but their raw power has made them the top choice for developers and AI enthusiasts who want to run these incredibly powerful models right from their own desk. And our source material from Bryson really hits the nail on the head here. This isn't just a simple story of more is better. No, the real story is in the details, those specific differences in the architecture and the memory that really define what each card is built to do. All right, let's get down to brass tacks. It's time to look at the numbers. We're going to strip away all the marketing hype and just look at the raw data. This is the tail of the tape, where we see exactly what each of these GPUs is bringing to the fight. Okay, wow, just looking at these raw numbers, you can immediately see the 5090 flexing its muscles. We're talking clear upgrades in VRAM, the memory bus, and the overall bandwidth. And these aren't just little bumps. They represent a pretty significant generational leap. Let's break down what these key numbers actually mean for you. First up, VRAM. You got to think of VRAM as the size of your GPU's workbench. Now, the RTX 4090 has a really generous 24 gigs, which is a lot, but the 5090 blows that up to a massive 32 gigabytes. That extra workspace is absolutely critical if you want to load up those larger, more complex AI models without making any compromises. And then there's the data highway, right? The memory bus. The 5090's 512-bit bus is like a super wide, multi-lane freeway, letting it move data at a mind-boggling 1.792 terabytes per second. That's nearly an 80% increase over the 4090, and it's so important for feeding those processing cores without creating a traffic jam. Now for the stuff that really matters for AI, raw processing power. We measure this in something called TOPS, that's trillion operations per second. Yeah, trillion. The RTX 5090, with its new 5th-gen tensor cores, is pushing over 3,300 AI TOPS. That is more than double the already incredible 1,300 TOPS of the 4090. On paper, its AI horsepower is just in a whole different league. Okay, next up, the Blackwell leap. Because look, big numbers are great and all, but the real magic, the secret sauce, comes from the design underneath it all, the architecture. See, a new architecture isn't just a minor tune-up. It's more like swapping out a V6 engine for a completely redesigned V8. It totally changes how every single piece works together, which unlocks completely new levels of performance and efficiency you couldn't get before. And Blackwell brings some killer advantages to the table. The most exciting thing for AI folks is the support for new data formats, things like FP4 and FP6. Just think of them as these super efficient compressed languages that let the GPU process AI stuff much, much faster and more efficiently. It saves you both time and power. Which brings us right here to the AI showdown. This is where the rubber meets the road. How do all these specs and architectural upgrades actually perform when you're running the large language models we're all so excited about? So in your average everyday testing, the RTX 5090 is consistently delivering about 25 to 30% more tokens per second when it's running these language models. In simple terms, that means you get your answers, your code, your generated text that much faster. It's a really noticeable speed boost. Buts, and this is a big but, in certain situations where the software and the model are just perfectly optimized for that new Blackwell architecture, whoa, that performance gap can just explode. We're talking improvements of up to 72%. This shows you the true unlocked potential of the new card, which we're going to see a lot more of as software starts to catch up. So this leads us to a key question, and it might be the most important one for anyone thinking about buying one of these things. With all this insane power, do you actually need that massive 32 gigabytes of VRAM? Well, the answer, as it always is, it depends entirely on what you want to do. Let's look at this breakdown from our source. The really popular 7 billion parameter models, they run great with about 12 to 16 gigs of VRAM. If you step up to 13 billion parameter models, you'll want somewhere between 16 and 24 gigs. So you can see, the 4090's 24 gigabytes is kind of the sweet spot for a huge range of powerful models. But to run those truly massive 32 billion parameter models without any compromise, that's where the 5090's 32 gigs becomes pretty much essential. And that brings us to our final section, your perfect match. We've seen the specs, we've analyzed the architecture, we've looked at the performance, so now let's put it all together and help you make the right call. Are you gonna upgrade or stick? A huge factor in this whole decision is future-proofing, right? AI tech is moving at lightning speed. So is spending that premium price on the RTX 5090 a smart investment for whatever's coming next? Well, the analysis suggests that, yeah, probably. Because of those advanced features baked into the architecture, like those new data types we talked about, the 5090 has a potential long-term performance edge that could be as high as 72% over the 4090 once developers fully learn how to tap into all its new capabilities. So here's the bottom line. The decision really boils down to your specific needs. The RTX 4090 is still an incredibly powerful, efficient workhorse that offers amazing value and is perfectly capable of handling a huge range of today's AI models. But if you're a power user who needs the absolute fastest single card, you want to run the biggest models out there, and you're all about being ready for the future of AI, then the RTX 5090 is the clear winner, even if it costs more. It really makes you wonder, doesn't it? I mean, with the leap we've just seen going from the 4090 to the 5090, what kind of insane power and memory is the next generation of AI going to demand? What will an RTX 6090 even look like? Hey, if you want to dive even deeper into the benchmarks and get the full technical rundown, the link to our source material is right there on your screen and also down in the description. It's really worth a read. That's all for now.